Ever pondered why a lightweight car or bike is earthbound, but a heavyweight airplane soars freely in the sky? It's a paradox that has intrigued many. You might think it's all about weight, but there's so much more to it. It's the fascinating world of aerodynamics, where forces of lift, drag, gravity, and thrust come into play, and how they interact with different vehicles. But don't worry, we're not leaving you hanging with just that. Stay tuned as we unravel the mystery of flight. To understand flight, one must first grasp the principles of aerodynamics. Now, what is aerodynamics? It's the study of how air moves around objects, and it's key to understanding why planes fly, but cars and bikes don't. There are 4 forces at play here: lift, weight, thrust, and drag. Lift is the upward force that opposes the weight of the airplane and lifts it into the air. It's generated by the air flowing over and under the wings, creating a pressure difference. Weight, on the other hand, is the force of gravity pulling the airplane down. To fly, an airplane must generate lift greater than its weight. Thrust is the forward force that propels the airplane through the air. It's produced by the engines pushing air out behind the plane, according to Newton's third law. For every action, there's an equal and opposite reaction. Drag is the backward force that resists the airplane's forward motion. It's caused by the friction and pressure difference between the airplane and the air. An airplane is designed to maximize lift and thrust while minimizing weight and drag. The wings are shaped to generate more lift. The engines are built to produce enough thrust, and the materials used are lightweight, but strong enough to withstand the forces of flight. So, it isn't about the weight after all, but how you use it. Now let's turn our attention to our everyday travel companions, cars and bikes. You might wonder, despite being lightweight, why can't these vehicles fly? The answer lies in their design. Cars and bikes are optimized for ground travel, and they simply do not incorporate the principles of aerodynamics necessary for flight. Consider the design of a bike or a car. They are built to be aerodynamic, yes, but that's to reduce drag for speed on the road, not to generate lift for flight. Their structures are also not designed to withstand the forces of flight. Furthermore, the engines in cars and bikes are not designed to generate the thrust needed for liftoff and sustained flight. It's also important to note that the wheels of cars and bikes, essential for their function, would be a hindrance in the air. They add extra weight and do not contribute to flight in any way. Well, that explains why your bike won't suddenly take off during your morning commute. What about the materials used in aircraft manufacturing? Do they hold the secret to flight? You bet they do. Airplanes are primarily made of aluminum, a lightweight yet strong material perfectly suited for high altitudes and varying temperatures. Its strength-to-weight ratio is one of the highest among metals, making it ideal for constructing aircraft. Then there's titanium, used in areas exposed to extreme heat and pressure. It's as strong as steel, but 45% lighter, and it can withstand temperatures up to 600 degrees Celsius. And let's not forget about composites like carbon fiber, which are even lighter and stronger than aluminum and titanium. They're used in modern aircraft to reduce weight and increase fuel efficiency. In contrast, cars and bikes use heavier materials like steel and iron. They're sturdy, sure, but they lack the strength-to-weight ratio needed for flight. They're designed for durability on the ground, not for soaring in the sky. So it's not just about design, but also the right choice of materials. So, why does a heavyweight airplane fly when a lightweight car or bike can't? It all comes down to the principles of flight, the design, and the materials used. We've walked through the science of flight, highlighting the concepts of lift, thrust, drag, and gravity that make flying possible. We've compared this with the dynamics of cars and bikes, which are designed for ground-based movement and lack the necessary features to overcome gravity and achieve lift. We've also dived into the materials used in aircraft manufacturing. Aircraft are made from lightweight, durable materials that can withstand the strains of flight, while cars and bikes are made from heavier materials that can't. All these factors combine to answer our initial question. Despite their weight, airplanes can fly because they are designed and built to do so, while cars and bikes, despite being lighter, are not. And there you have it, the marvel of flight unmasked. Until next time, keep your curiosity ignited